Here's another example where you're asked to kind of do the opposite of what you're used to. So you're given traits of the graph of a rational function, and then we're supposed to come up with the equation for that rational function. So this time we want a vertical asymptote at x equals 3, a horizontal asymptote at y equals 0, a hole at -3, -1/3, and a y-intercept at 0, -2/3. Okay, so the goal is to build this rational function. So it's going to be a polynomial over a polynomial. I know that much. Again, it helps to build this function. Think about where each of these traits come from in terms of the equation. So vertical asymptotes correspond to zeros of the denominator. So if x equals 3, that comes from setting the denominator equal to 0, then x minus 3 must be a factor in the denominator. So we should put an x minus 3 in the denominator here. Okay. Horizontal asymptote comes from comparing the degrees of the numerator and denominator. When you have a higher degree in the denominator, that's when you get a horizontal asymptote at y equals 0. So this indicates higher degree in the denominator. Okay. Now there's a hole at -3, -1/3. So if you think about, okay, well, when do I get a hole? When I'm looking at the equation and I'm trying to draw a graph, how do I know there's a hole? And the answer is it comes from a factor that cancels. So it's a and in fact it's a factor. Well, it's a factor of the numerator and denominator. That cancels. That's when you end up having a hole. And if there's a hole when x equals -3, so that means that x plus 3 is the corresponding factor. That's the factor in the numerator and the denominator that cancels. Okay. Now notice the y value is -1/3. If you cancel, oh, well, yeah, if you cancel the x plus 3's right now, you'll have 1 over x minus 3, and plug in this x coordinate -3, you're going to get 1 over -6, if you can kind of picture that. You're not going to get -1/3. So here's the thing. You may have some leading coefficient in the numerator. I'm going to put a. You could also have some coefficient in the denominator. The a could actually account for both of those. So I'm going to, if a is a fraction, so I'm just going to leave it like this. So we know we have a factor of x minus 3 in the denominator. We know we have a factor of x plus 3 in the top and bottom because of that hole. Now there could be any number out front times these factors, and it would still have the traits that we've talked about so far. So you could have like 500 here or -2, and this thing would still have vertical asymptote at x equals 3 and a hole when x is -3. So you can use this coefficient out here to make sure that you get the right y coordinate for the hole. So when we're looking at the exact location of the hole, remember what you do is plug in the x coordinate of that hole, plug it into the simplified function. So after you've canceled the x plus 3's on the top and bottom. So you want to plug in -3 to that remaining factor, -3 minus 3. So I'm substituting -3 from the x coordinate for the hole. And so this is a over -6. And we know that the y coordinate is supposed to be -1/3. So set whatever we get this equal to, whatever result you get when you plug in the x coordinate, set it equal to -1/3 so that our y coordinate comes out to -1/3. Okay, so to solve this equation, I would multiply both sides by -6. That'll clear the denominators. So that'll cancel the negative 6 here, so we have just A. And so 6 divided by 3, that's 2. Negative 1 times negative 2, that's positive 2. So the A right here is positive 2 times x plus 3 over x plus 3 times x minus 3. I'll write that as x squared minus 9. So there's the equation of the rational function, at least that meets these first 3 requirements. Note that, okay, vertical asymptote at x equals 3. Yeah, because that's a 0 of the denominator. Horizontal asymptote at y equals 0. Yes, because we have a higher degree in the denominator. Whole at negative 3. Yes, because these factors will cancel, so that tells us there's a whole at negative 3. And if you plug in, if you reduce it and plug in negative 3, you will get negative 1/3. I know that's not obvious from the form I have here, but it will be satisfied. So the one thing left that we haven't talked about is the y-intercept at 0, negative 1/3. So let's just verify that what we've come up with satisfies this requirement here. So if we check that this requirement is satisfied, see if we need to make any adjustment before we even worry about what adjustment that we would need to make. Start by plugging in start by checking if your existing equation here already satisfies it. So remember that you get the y-intercept by evaluating the function at 0. So f of 0 would be 2 times 0 plus 3, so 3, over 0 minus 9, negative 9. So you get negative 6 over 9, which reduces to negative 2 over 3. So we do get the correct y-coordinate there for the y-intercept. So this really is our final answer. This satisfies all 4 of the listed traits.